please start.
Hello, everyone. Thank you for taking the time to attend this talk. I'm Al-Hassan Maklid, research assistant and PhD candidate at TU Ilmenau. And today I'll be presenting on behalf of my colleagues, Florian Weidner and Professor Wolfgang Brohl, our work on augmented reality avatars, titled Investigating User Embodiment of IK Avatars in Smartphone AR. All right, so recent smartphone devices have provided access to augmented reality to average users through the help of frameworks like ARCore or ARKit. And this gave more room for advanced AR games, such as with social features such as Pokemon Go or Harry Potter Wizards Unite. This also further opens room for cross-reality social platforms for smartphone AR and VR users. And to allow for collaboration social VR interactions that are similar to that of VRChat or Rec Room or AltspaceVR, social VR applications enable users to express themselves through embodying avatars, and this, of course, requires some form of body tracking. However, due to the smartphone's limitation in tracking user body movement and behavior, smartphone AR does not provide a level of social interaction similar to that of those VR applications that were just mentioned. And for this, we propose our solution, ARIKA. So using only tracking information from the smartphone, we aim to infer users' position to drive their avatar's pose through Inverse Kinematics. So previous studies on avatars and user embodiment explored two main aspects, and these are representation, which is how does the avatar look like, their gender, rendering style, whether they're realistic or cartoonish. And the second thing is behavioral realism, which is how does the avatar move, behave, or animate, and this, of course, is done via tracking the user. In current commercial VR head-mounted displays, the avatars mimic user movement through tracking the head-mounted display and two controllers, and this kind of helps track the user's head and hands, respectively. And this already allows for VR user gestures and like VR users to express themselves through like low-fidelity avatars, such as the one presented from Meta. Previous work has also explored the use of inverse kinematics to kind of fill in the gaps of untracked joints in the body, and thus allowing for high visibility avatars and therefore increasing behavioral realism. Recent work also further explores the use of IK as a solution for smartphone AR representation in a social smartphone AR scenario. So for example, Pose on the Go explores the use of sensor fusion of sensors that are found on the iPhone to track a smartphone AR user. And they further integrate IK to enhance the avatar's pose, even though Pose on the Go yields great results, and however, it is a little bit inaccessible due to the focus on iPhone sensors that aren't available on most smartphone devices. And moreover, the impact of those avatars, those inverse kinematic avatars on the user's sense of embodiment are yet to be explored. So we present ARIKA, a tracking solution for smartphone AR users. And ARIKA uses tracking information from just the ARCore to track the user's hand position and calculate a pose using IK. And we evaluate our system with respect to user embodiment and compare it with a motion capturing system that acts as our ground truth. So in designing the system, we focus on three main aspects, and these are where should the avatar's hand be, where should the avatar be standing, and how should the avatar move as the phone moves. So the phone's position and orientation from ARCore are used to manipulate a 3D model of the phone, or it's kind of like a digital twin of the phone. And this 3D model then acts as the target for the avatar's right hand. Then a point of destination is calculated from the phone, and this determines where the avatar should be standing from the phone as the phone moves in space. And using the phone's velocity and 5 different animations, 4 walking animations and 1 idle animation, we blend between those animations to improve behavioral realism in the avatar. And this is how the final blended animation looks like as the phone moves. We designed a study to compare the accuracy of our system against the commercial motion tracking system, OptiTrack, and compare both systems with respect to sense of agency, self-location, and body ownership. To do that, we invited participants to observe their avatars in an augmented virtual mirror and allowed them to execute a navigation and the pointing task. Each participant observed their avatar 4 times, so twice when their avatar was tracked with OptiTrack and twice with their avatar being tracked with ARIKA. And during each observation, they were either doing a navigation task or a pointing task. So for that, since we have a virtual mirror, we had to do a digital replica of our lab to be displayed in that virtual mirror as well. We also placed a marker that is scanned at the beginning of the study, and this helps overlaying the virtual world on the real world so that it kind of lines up one-to-one. For our study, we had 20 participants, 16 self-identifying as males and 4 as females. They had an average age of 27 years and an average height of 176.5 centimeters. We used the participant's height to further scale the 3D avatar, and this kind of helps them be on the same height when they're seeing themselves in that augmented mirror. Similar to Pose on the Go, we designed a task that asks participants to take certain steps in a frame of 20 seconds, so they move back and forth and right and left. And then we created a pointing task. This was done to nudge participants into moving their hands more often to avoid some sort of a static posture where they're holding their phone in front of them and just swaying back and forth. And during the pointing study, we had a grid of 8 augmented points. They're placed around the 3D space, and we asked participants to search for the point, approach it, and then once they feel they're close enough, then they would press on a button on the phone, and then the next point would appear. So our study procedure went as follows. Participants were greeted, then they filled the demographics form, and then based on a Latin square, they were provided one of the combinations of the task, so ARIKA with a certain task or OptiTrack with a certain task. And then they filled a user embodiment questionnaire with 12 questions. Each question measured one of the user embodiment 3 main structures, so self-location. This is the sense of being self-located inside one's body, and this is not to be confused with the sense of presence, which is the sense of being in a virtual environment. Agency, which is the sense of having motor control over one's body, and body ownership, which is the sense of ownership over one's body. And during this study, we collected data from the joint transforms from both the ARIKA avatar and the OptiTrack avatar. Our data was measured with an average rate of 81 frames per second, so that means we had transform data for each joint at a range of 81 frames per second. And during pre-processing the data, we averaged the position and rotation of each joint per second. Then we calculated the Euclidean distance and rotational difference between ARIKA and the OptiTrack avatar. Then we used a z-square approach to identify and remove outliers within 3 times the standard deviation from our calculated mean. And then we further investigated the subset of all the joints saved. So we saved many joints from the 3D model. However, the ones that were observed were hip, hand, elbow, shoulder, knee, and ankle for both the right side and the left side. And therefore, we totally observed and analyzed just 11 joints. The overall Euclidean distance error is 22 centimeters with a standard deviation of 13 centimeters across the 11 joints. We then calculated the distance for each side, right and left, across all tasks per individual task. And here, as you can see, the right side of the body, which was being tracked by the smartphone, has an overall less Euclidean distance error than the left side. We can also see how the error increases the further we move away from the right hand, which is the main joint that is actually being tracked by the smartphone. In comparison to Pose on the Go, ARIKA has an overall larger mean Euclidean distance error and standard deviation. The difference in the overall mean between ARIKA and Pose on the Go is 5 centimeters. And this definitely is due to the fact that ARIKA only uses ARCore's phone transform data as opposed to a fusion of different sensors. But ARIKA is successful in estimating avatar pose using only this data from ARCore without having a large Euclidean distance error. Finally, for embodiment, we evaluate our user embodiment questionnaire. So participants were provided a total of 12 questions, with 3 questions focusing on self-location, 3 on agency, and 6 on body ownership. And we performed repeated measures ANOVA to compare the effect of tracking on each question from the questionnaire. And for self-location, 1 out of 3 questions had a statistical significance, favoring OptiTrack over ARIKA. Participants felt that their body was not located where they saw their virtual body while using ARIKA. This is mostly due to ARIKA not having tracking information of parts of the body, such as the legs, for example. So also, ARIKA predicts a step is taken based on the velocity and displacement of the phone. So if a small step was taken, that wouldn't be visualized through ARIKA, therefore making the avatar appear in a little bit different location than that of the user's body, and therefore impacting the user's self-location. And as for agency, all three questions had statistical difference. And this kind of makes sense because when users move parts of their body that aren't being tracked, such as their left hand, for example, it didn't mimic their movement, which was kind of also creepy for them. Looking at the mirror and your reflection kind of does something different. And this impacted the user's overall sense of agency because they didn't feel that they have full motor control over their body. However, for body ownership, there was no statistical significance between ARIKA and OptiTrack in any question that explored body ownership. So as expected, ARIKA scored less than OptiTrack in embodiment. Although there is room for improvement for ARIKA, the median values for agency and self-locations were above the neutral values. And moreover, overall body ownership was not sacrificed when users were being tracked through ARIKA. So our work found out that using IK avatars for user representation in smartphone AR doesn't really impact users' sense of body ownership. However, IK avatars weren't enough to maintain user sense of location and agency. And this, again, is mostly due to the low tracking fidelity in smartphones. So what's next? Well, the easiest answer is like better tracking and pose estimation solutions. And this could be achieved by the use of sensor fusions, but hopefully more accessible ones other than ones that are just found just on an iPhone. And to explore more complex actions as well through blending more diverse animations in order to allow for more complex physical coordination as well. So not just navigation and pointing. And finally, we explored the sense of self-embodiment. However, it would be also interesting to explore the perception of other users observing an IK avatar and the IK avatar's impact on social presence. And this brings me to the end of my talk, and feel free to get in touch. I'll leave it for the Q&A. Thank you.
Thank you for your presentation. Okay, so we will move on to the Q&A session. Is there any?
Well, thanks a lot for your talk. You mentioned the differences in tracking regarding Euclidean distance, but you have a gut feeling about how visually different it may be? Just a feeling, subjective feelings?
Like for me,
between ARIKA and the OptiTrack thing.
Like as I said, it does feel a little bit weird because it's not really 100% tracking your full body. However, if we look at AR, usually you don't see your body unless, of course, if you move a phone. So I think it will be mostly interesting if we explore it from the other side of an observer that is observing this body. How would they feel? Would it feel weird that an avatar is moving a little bit mechanical? They're not really natural. Yeah, but I'm not sure if it will only be interesting to explore if there's mirrors everywhere in an augmented virtual environment.
Thanks a lot.
Thank you for your great presentation. And you've mentioned complex animation blend tree as next step. And can you explain it in detail?
Yeah, definitely. So the blending that we did in ARIKA is just walking blending. So it's navigational blending. So you walk back and forth and sideways and so on and so forth. However, for example, and I think this is also, it goes back to the first question. Let's say you bend over or you crouch. Now this wouldn't register with ARIKA, right? So it doesn't really allow for a lot of complex activities that could be done by the user. And therefore, if we add more expressiveness, for example, a small wave as you wave the phone, or allowing for leaning. So what if the user was leaning on one leg or the other? How would you present that? And I think this is what I meant by adding more complex animations or better blends.
Thank you for the interesting talk. So sorry if I missed it, but I think you mentioned more or less the scores for self-location and agency, but I'm not sure I heard for body ownership, what were more or less like the main scores of them, and I was wondering if you had an idea of why there was no differences between the methods on the score of ownership compared to the other dimension of embodiment.
I have an assumption that it has to do with user representation more visually. So like one of the comments that we got, so we had an older person testing our application, and she said that the female avatar was too young and it didn't really represent her. And therefore you most probably would get similar scores. Right? So this would be my initial assumption for it. And maybe it would be interesting to explore this if you do, like, if you try to do proper, I don't want to say like go all in with 3D scanning, but if you do allow users to maybe create their own avatars and kind of represent themselves, and then you can see if, evaluate it that way.
Okay, thank you. So the scores were relatively low. That's why you're like, in terms of ownership.
In terms of owner, I'm not sure if I have a slide for that, but yeah, maybe I'll share it with you after. But everything was above neutral.
Okay, everything, so not only the application.
Yeah.
Okay, thank you.
Thank you.
Okay, thank you. We run out of the time, so let's thank the speaker again. Thank you very much.